Our topic today is a piece of cake, just for fun. We have something called hydraulic devices. We have few devices. We need to learn how can we estimate the discharge. The first one called orifice, the second one called weir, the third one called gate. So after completing this chapter, we can calculate the flow discharge Q through orifice, through weir, through or under gate. Let's start with the first one, orifice. Orifice, the meaning of orifice is a hole in the wall of a container through which water may flow. If you have a container, circular container, or square or rectangular container, and this container is filled with water. If you are doing a hole at this location, we expect flowing of water. That makes sense. If you do a hole, whatever the shape of the hole, circular or square or whatever the shape of the hole, we expect flowing of water. So the meaning of orifice is a hole in the wall of a container through which water may flow. Like this one, or this one, or this one. And the exit of the orifice is different. Sometimes we have thin wall, sometimes we have thick wall, sometimes we have thick wall, but we have something here like chamfer of the exit. Generally, the wall is assumed to be thin and the edges of the hole are square, but many variations of geometry are possible. How much water are flowing through this orifice? Q equals CA square root of 2GH. We understand what is the meaning of G. G is called acceleration of gravity. Acceleration of gravity. Sometimes it's 9.81 Newton per per square meter. I'm sorry. Meter per second square, or 32.2 feet per second square, based on what are the units you are using. H is the total head measured from the center of the orifice. A is the cross-section area of the orifice. What is the cross-section area? C is called discharge coefficient based on what is the shape of this orifice. Sometimes we have this shape. Sometimes it's a sharp exit. So based on what is the shape of the orifice, we can figure out what is the value of C. Most of the time it's given. So C is a coefficient. The experimental value of C for a square edge orifice varies depending on the size and the shape of the orifice. The common value for this coefficient equal 0.62. So sometimes the problem is not given the coefficient of discharge, so you can assume it 0.62. We have example here. Find the discharge Q through 6-inch diameter square edged orifice, discharging freely. The water surface elevation of the impoundment is 220 and the elevation of the center of the orifice is 200. Take C equal 0.65. I cannot understand anything. Okay, let's draw. We have a wall. This wall has a water here. This water surface at elevation, the water surface elevation is 220 feet. We did hole, which is called orifice. The diameter of this hole is 6 inches. Can you tell me what is the area of this orifice? Yeah, I can. By divide 4 times 0.5 square. I can tell you what is the area of this orifice. What is the meaning of 0.5? 6 inch, if you convert it to feet, it will be 1/2 feet. So the area will be by divide 4 times 0.5 square equal 0.196 feet square. C is given 0.65. Yeah, one more information is given here. The elevation of the center of the orifice. So at this center, the elevation here is 200. Anybody can tell me what is the H value? What is the height between the center of the orifice and the water surface? H will equal 220 minus 200. It will be 20 feet. So the discharge, which equal CA square root 2GH, can be found. C 0.65, area 0.196, square root 2G 32.2, H 20 feet. I can figure out that this charge, it's piece of cake. 2 times 32.2 times 20 under square root times 0.196 times 0.65. Your value will be 4.5 cubic feet per second. Any question? So please read your problem carefully. We understand that if you have orifice, we will have this charge equation Q equals CA square root 2GH. So we are looking for these terms. What is the value of C? What is the value of area? What is the value of H? Area, cross-section area of the orifice. The diameter is given, so I can figure out the area. C is given. This is charge coefficient. What is the value of H? H is the distance, the vertical distance between the center line of the orifice and the water surface. So the final value for the discharge equal 4.5. Any question? Any question? So probably we can have problem like this in the exam. We have two types of flow condition for orifice. Sometimes the discharge is free discharge. Sometimes it's a submerged discharge. I'm sorry, what you mean? We don't have here water, or the water level here below the center line of the orifice. So the discharge is flowing freely. Or we have water here and the level of the water above the center line of the orifice. So your flow, that makes sense because this water level higher than this water level, so we can expect flow. But this flow is submerged flow. Keep in your mind, H is the distance between center line of the orifice and the water surface. If this flow is free. If we have submerged flow, so H will be the distance between this water level and this water level. Big difference. What is the value of H if you have free discharge? What is the value of H if you have submerged discharge? So H is measured to the center of the orifice. H is measured to the lower water surface. Be careful. We have example here. We have example. Example number 2. Find the discharge Q through rectangular orifice. So this time is not circular, it's rectangular orifice, 4 inch by 6 inch. The dimension of the hole is a rectangular shape with 4 inch by 6 inch with square edges, T equal 0.65, discharging submerged. Wow. So here is the wall. We have a water level here, and we have a water level here, and we did hole which is rectangular. So we expect to flow through this hole. The area of this hole 4 inch times 6 inch. So will be 0.167 feet square. Guys, remember the dimension of the orifice is 4 inch. I divided it by 12 to convert it to feet. 6 inch, I divided it by 12 to convert it to feet. So the final area will be feet square. Discharge coefficient is given 0.65. Why you draw water level here and water level here? Because this one is discharging submerged. The water surface elevation of the impoundment 220, and the elevation of the water surface of the discharged water is 215. Can you tell me what is the value of H? I told you just a moment ago, if you have submerged flow, the value of H is the difference between this water level elevation and this water level elevation. I don't care about where is the center line of the orifice because we have submerged discharge. So the value of H will be 220 minus 215, it will be 5 feet. This difference, 5 feet. So the discharge will be CA square root 2GH. Go ahead and put your number. C 0.65, area 0.167, square root 2G 32.2, H is 5 feet. Your final answer will be 1.94 cubic feet per second. Any question? So be careful and read your problem carefully. Do you have free discharge or submerged discharge? Because the only difference between this case and this case, what is the value of H? Submerged between this water level and this water level. Free, the H is the distance between the center line of the orifice and the water level. Any question so far? Any question? If you have any question, let me know. The second structure, which called weir. Did you see a weir before? Weir. Weir is a structure that, like an orifice, regulate the flow of water out of an impoundment or reservoir. Generally, weir consists of horizontal surface over which water is allowed to flow. Horizontal surface over which water is allowed to flow. These structure weirs are widely used to measure as measuring devices. We can use them to measure discharge. For example, let's watch this video. What is the meaning of weir? I'm not sure if you watched it before or not. We have a canal here. This canal probably collecting drain water coming from rainfall or something like this. And we have a bridge. This bridge, if you have a truck or a motorcycle or something, so you can draw on Florence line. It's not our topic. The water is coming from this side to the other side. We have something here. We have something here. Can you see? This one called weir. We can, believe me, we can measure the discharge by this weir. How? We will see, but keep watching. So now you can imagine what is the meaning of weir. Weir is a step, just a step with width, and this structure regulate flowing of water from one side of the canal to the other side of the same canal. Right now, by some measurement, we can calculate how much water are flowing or is flowing. Okay, we have different types of weirs, sometimes based on what is the shape of this step, sometimes called sharp crested weir, broad crested weir, or ogee weir. I think this shape is rectangular. This shape is rectangular shape because we have a rectangular weir. Sometimes it's triangular or called V-notch weir. Sometimes it's a trapezoidal weir. These sides are sloped. So I think this video is showing up a rectangular weir. Anyway, so this slide just to show you we have different types of weirs based on what is the shape of the cross section or based on what is the shape of front view shape. Okay, let's start with the rectangular weir. We have a rectangular weir, so we have water level here above or higher than the water level here. If you go back to the video, we have two different levels. The water level behind the weir is higher than the water level on front of the weir. So we have water difference between this one and this one. The discharge above or over this weir equals CLH to power 3 divided 2. C is a coefficient. Discharge coefficient will be given based on the type of the weir. L is the effective crest length. This length from this side to this side. If you go back to the video, the width of this crest between, I can show it to you. So L in this case is the distance between this side to this side. This is L. Okay. And H is the water height between the surface of the top surface of the weir and the water level behind the weir. This is H. So if you go back to the your video, H will be the height between the level, the top level of the weir and the water surface, this little height. So if you can measure what is the width of this weir, what is the height of water above the top surface of the weir, and using the value of C, the coefficient, the discharge coefficient, you can figure out the discharge over this weir. Let's do an example. I think we have example here. No, we don't have example for this one. Anyway, it will be very direct to problem. What is the width of this weir? What is the H? But remember, we are talking right now about weirs, rectangular weir. So the value of H is the height of water between the top surface of the weir and the water surface is called in the upstream. This one called upstream. This was called downstream. The water is flowing in this direction. So we have coefficient, discharge coefficient, length, which is the width of the weir, and the H value, so CL times H to power 3 divided 2, I can figure out the value of Q. The second type of weir, which called sharp crested weir. This crest, which is the top, is very sharp, like this, sharp, which called sharp crested weir. The discharge equals CL H to power 3 divided 2. C, discharge coefficient. H is the height between the top crest point and the water level in the upstream. L is not the width. No, L equal L bar minus 0.1 N times H. L bar is the actual length. The actual length here means width. Between this side and this side is L bar or L prime. If you subtract L prime minus 0.1 N number of contraction. In this case, we have one contraction, another contraction, so it's 2. So N is the number of contractions. H is the water height above the crest of the weir. Okay? Let's do we can determine or we can calculate the value of C, which is the discharge coefficient, by this expression 3.27 plus 0.4 H, the height of water, divide P, the height of the weir. Okay, let's do an example. Just a second. we are looking for what is the value of this charge Q for sharp crested weir. So this charge equals C L H to power 3 divided 2. That's right. If the crest elevation, this elevation at the top of the weir is 282, and the impoundment elevation water it should be here. What is the elevation here? 283.75. Okay. What is the value of C? 3.27 plus 0.4 H divide B. What is the value of H? The difference between top surface of the weir and the water level, how much? 283.75 minus 282, it will be 1.75 feet. What is the value of P? What is the height of this weir? What is the height? P is the height of the pier, which is given here 2.85. So I can figure out the value of C, 3.27 plus 0.4, H 1.75, divide P 2.85. So this value will be 3.5. What is the value of L? L equal L prime minus 0.1 NH. That's right. There you go. What is the actual width of this weir? Is given here 5.33 minus 0.1. How many contraction? We have first contraction, second contraction. So we have two contraction. H 1.75. So we can figure out the value. .98. We are done. So C equal 3.5. L equal 4.98. H equal 1.75 to power 3 divided 2. This discharge will be 40.4 cubic feet per second. Any question? So make sure if we are talking about sharp crested weir, we need to figure out what is the value of C, what is the value of L before using the discharge equation.
Can you show what's N again? The constructions you said?
Okay. To construct this weir, we will do these steps. One contraction, another contraction, and then here is the weir. Means contraction. We have this the total width. We did I'm sorry. Wait. The total width between this point and this point. We did contraction in the cross section. Probably I can show it one more time for this video. Okay, just a second. Can you see here? we are doing contraction in the cross section of the canal. Can you see here from this side we have first step, second step, third step, fourth step. So we have 4 contraction. We are reducing the cross section of the canal. So from one side, please tell me how many contractions. This is the first one, and this is the second one. So we have 2 contractions, so n equal 2. We should expect the same number on the other side to make it symmetry. So n is the number of contractions. I did contraction like this, another contraction like this to build the weir. So we have 2 contractions. This value of n will be used with figuring out what is the actual width of the weir. Any other question?
Thank you. That makes sense.
Yeah. Sometimes, but this one just for your information will not be included in the exam. Sometimes the weir looks like a triangle, which called V notch, and the discharge will be C tan theta divided 2 h to power 5 divided 2. Theta is the angle between this sloped side and this sloped side. This is the angle theta. So C coefficient tan theta divided 2 h to power 5 divided 2. Variation of the sharp crest weir is a triangular or sometimes called V notch. We have example here. Find the discharge flowing over 60 degree. So this V notch has angle here 60 degree, and we have a water. The H, I forget something here. H is the total height of water above the vertex of the triangle. This is the H. So H is given here. This total height H equal 4 inch. And the discharge coefficient equal 0.82. Okay, so the discharge equal C tan theta divided 2 h to power 5 divided 2. That makes sense? So C 0.82 tan 60 degree divided 2 time h. This h equal 4 inch. I think 4 inch equal 0.33 feet. So we have 0.33 feet to power 5 divided 2. I can figure out that this charge tan 30 time 0.82 time 0.33 to power. So this one will be 0.029 or 0.03 cubic feet per second. If you have weir looks like V notch or triangular, the angle theta between this sloped line and this one, h is the total height between the water surface and the vertex of the weir, C is a discharge coefficient. The last one, which called gate. Do you know what is the meaning of gate? Especially slice gate. Let's watch this video and see what's going on. So we have different types of gates to control flowing of water from a source of water to a canal or channel or something like this. So a gate is an opening usually for the purpose of flowing down of allowing, for the purpose of allowing drawdown, emptying of the impoundment, or provide enhanced discharge quantity to the stream fed by the impoundment. Usually having a rectangular shape, gates are sometimes called head gates, diversion gates, and the slice gate. What shown in this video is a slice gate. Slice gate regulates discharge in a canal. In this case, one of the rectangular gate is completely open. The lifting mechanism. Did you see the mechanism in this video? We have mechanism here with vertical axis here, and the gate looks like this. So if you rotate this mechanical part or this part, the gate will be raised up, so the water can flow underneath the gate. Anyway, can be seen above the gate. Sometimes we have water here. If you open this gate, this flow looks like this. Sometimes after you open the gate, the water will go through and then rise up. Sometimes we have submerged flow, the water level here above the opening of the gate. So the water surface profile may be from a flat surface like this one, or hydraulic jump. We can expect hydraulic jump here. Anybody can tell me, how can I expect this one or this one? How can I expect the hydraulic jump? Behind the slice gate. Okay, go ahead here and find Froude number. After a certain distance, find a Froude number. Based on the Froude number, I can tell you your flow is supercritical or subcritical. If you have something between supercritical and subcritical, we expect here water hydraulic jump. Do you remember that? So all of these stuff we covered before. The third one, we have submerged condition. The water level here is submerging the exit of the gate. Anyway, the discharge underneath the gate equals CLH to power 3 divided 2. C is a coefficient, will be given. L is the width of the gate. H head above the center of the opening under the gate. The center between the distance between the center of the opening under the gate and the water level. So if you have a gate like this and you open it for this distance, and here is the water level, whatever the water level here, H is measured between center line of this opening to the water surface in the upstream. Here is H. Based on this H and the width of this gate, which is L, and the coefficient C, I can figure out how much discharge is coming outside. We don't have examples on this one,